Good morning to all. I am Subarani, Associate Professor, Emmanuel Sir College of Pharmacy. Today we discuss the topic gastrointestinal agents. The definition of gastrointestinal agents are: these agents are used in the treatment of gastrointestinal tract disorders, that is, achlorhydria, hyperacidity, diarrhea, and constipation. Okay, the gastrointestinal tract agents are these agents are used in the treatment of gastrointestinal tract disorders. The disorders are achlorhydria, hyperacidity, diarrhea, and constipation. Or the another one definition is these agents are used in the treatment of gastrointestinal disorder are called as gastrointestinal agents. Some chemicals which are used in the treatment of gastrointestinal disorder are called as gastrointestinal agents. Then classification of gastrointestinal agents. First type is gastric acidifiers. Example is dilute hydrochloric acid. Then second one is antacids. They are further classified in two types. First one is systemic or absorbable antacid. The example of systemic antacid is sodium bicarbonate. Then second type is non-systemic or non-absorbable antacid. So antacids are two types, systemic and non-systemic antacids. The non-systemic antacids examples are aluminum containing antacids, calcium containing antacid, magnesium containing antacids, combination antacids. So first, antacids are two types, systemic and non-systemic. Then systemic antacids are example sodium bicarbonate. Then non-systemic antacids. Non-systemic antacids are further classified aluminum containing antacid and calcium containing antacid, then magnesium containing antacids, and combination antacid. The examples of combination antacids are aluminum hydroxide and magnesium hydroxide, then aluminum hydroxide gel and magnesium trisilicate. These are the example of combination antacids. Then third type is protectives and absorbents. Third type is protectives and adsorbents. Then bismuth containing compounds, for example bismuth subcarbonate, bismuth subnitrate, and milk of bismuth. Then activated clays. The example is light kaolin, activated charcoals. Then third type is protectives and adsorbents. Example is bismuth containing compounds and activated clays. Then bismuth containing compounds is examples bismuth subcarbonate, bismuth subnitrate, and milk of bismuth. Then second type activated clays, example light kaolin and activated charcoal. Then fourth type is cathartics. Cathartics are two types, laxatives and purgatives. Laxatives, the examples are methyl cellulose, sodium carboxy methyl cellulose, and liquid paraffin. Then purgatives, the examples of purgatives are magnesium hydroxide, sodium potassium tartrate, etc. So the classification of gastrointestinal tract agents are gastric acidifiers, and second one is antacids, third one is protectives or adsorbents, then fourth one is cathartics. Okay. Then achlorhydria. Achlorhydria defined as the condition in which there is no secretion of HCl in stomach. The HCl is used in digestion of food in stomach. Okay. Then achlorhydria or hypohydria means in which there is no secretion of HCl in stomach. Hydrochloric acid is not secreted in stomach. Some symptoms are obtained in this form for frequent bowel movement, sometimes mild diarrhea, epigastric pain, and abdominal pain. Then sensitivity to spicy food. So these are symptoms of achlorhydria. Achlorhydria defined the condition in which there is no secretion of HCl in stomach, but some symptoms are obtained: frequent bowel movement, then mild diarrhea, epigastric pain and abdominal pain, then sensitivity to spicy food. Then some reasons for achlorhydria. First one is gastric mucosal atrophy. Then second one is stomach carcinoma. Then third, gastric polyps. Then fourth one is chronic nephritis. Then chronic alcoholism. Then tuberculosis, that means TB. Hyperthyroidism. So these are the reasons of achlorhydria: gastric mucosal atrophy, stomach carcinoma, then gastric polyps, gastric nephritis, chronic alcoholism, tuberculosis, and hyperthyroidism. Then drug used in the treatment of achlorhydria. Some medicines or some drugs are used to treat the achlorhydria. They are dilute hydrochloric acid used for the treatment of achlorhydria. So it increases gastric HCl level in stomach. Okay, some drugs are used in achlorhydria. The most important drugs are dilute hydrochloric acid. The formula of dilute hydrochloric acid is HCl. It is used for the treatment of achlorhydria, and the use of dilute hydrochloric acid to increase gastric hydrochloric acid level. Then first one, hydrochloric acid. The molecular formula of hydrochloric acid is HCl. The molecular weight is 36.46 gram. Synonyms or another name of hydrochloric acid is muriatic acid. In properties, it is colorless fuming liquid, it is pungent odor, it is very soluble in water, it reacts with the silver nitrate to form white precipitate of silver chloride. Silver nitrate AgNO3 plus HCl gives AgCl. Okay, it reacts with alkali to form salt and water. It reacts with potassium hydroxide or sodium hydroxide to form a salt, sodium chloride or potassium chloride, and water. Okay, these are the properties of hydrochloric acid. So it is colorless and fuming liquid. It has pungent odor. It is very soluble in water. It reacts with silver nitrate to form white precipitate of silver chloride. It reacts with alkali to form salt and water. Then uses. The uses of hydrochloric acid is, it is used as acidifying agent. It is used for extraction of alkaloids. It is used in gastric acidifiers. So these are the uses of hydrochloric acid: acidifying agent and used for extraction of alkaloids, then gastric acidifiers. And storage condition. It should be stored below 30 degrees Celsius. In glass toppered container, hydrochloric acid is stored below 30 degrees Celsius in glass toppered container. Then chemical incompatibilities. With alkalids, the salt of silver, mercury, and lead. Then next topic is antacid. Antacids are the drugs or preparations which neutralize the excess hydrochloric acid secreted in the gastrointestinal tract. These drugs give relief of pain caused due to hyperchlorohydria. Antacids are the drugs or preparation to neutralize the excess of hydrochloric acid. Chlorhydria means less amount of hydrochloric acid secretion, but antacids are the drugs which are neutralize the excess hydrochloric acid and secreted the gastrointestinal tract. These drugs give relief of pain caused due to hyperchlorhydria. The another one definition is antacids are the drugs which are usually weak bases used for neutralizing excess acid in the stomach of the patient suffering from hyperchlorhydria. So, antacids are the drugs which are usually weak bases. It is used for neutralizing excess acid in the stomach of the patient suffering from hyperchlorhydria or hyperactivity. Some ideal characteristics of an antacid. So the good antacids are, it should not be absorbable and cause systemic alkaloids. It should not be absorbable and cause systemic alkaloids. Then the antacids should not be laxative or cause constipation. It should exert effect rapidly and over a long period of time. The antacids are exert effect in rapidly and it gives a long period of time. The buffer range of antacid is then pH 4 to 6. It should not produce large volume of gas. It should be palatable and inexpensive. A good ideal antacids are not inexpensive. It should probably inhibit pepsin. Then in stomach, the pepsin is secreted, but the good antacids are used to probably inhibit the pepsin. Then classification of antacids. First one is systemic antacids. Second one is non-systemic antacid. Systemic antacids. These are also called as absorbable antacids. The systemic antacids are called as absorbable antacid. They are water soluble and get readily absorbed and produce systemic electrolyte alterations and finally systemic alkaloids. So the systemic antacids are absorbable antacid. It is easily soluble in water and get readily absorbed and then produce systemic electrolytes and finally systemic alkaloids. It causes retention of sodium and electrolytic disturbances. Then systemic antacids causes retention of sodium and electrolyte disturbances. Due to this acid-base balance of the body gets disturbed. For example, sodium bicarbonate. The systemic antacids is acid-base balance of the body gets disturbed. For example, sodium bicarbonate. Then second type is non-systemic antacids. These are called as non-absorbable antacids. Systemic antacids are dissolved in water and it is called as absorbable antacids, but non-systemic antacids are called as non-absorbable antacids. These compounds are generally water insoluble, so do not get absorbed to a significant concentration in the system. So systemic antacids are water soluble, but non-systemic antacids are water insoluble. These are further classified as aluminum containing antacids. These are further classified as aluminum containing antacids. Example, aluminum hydroxide and aluminum phosphate. So aluminum containing antacids are aluminum hydroxide and aluminum phosphate. So non-systemic antacids are further classified as aluminum containing antacid, calcium containing antacids, magnesium containing antacid, and a combination antacids. So first one is aluminum containing antacid, example aluminum hydroxide and aluminum phosphate. The second one is calcium containing antacid, example calcium carbonate, calcium hydroxide, tribasic calcium phosphate. These are calcium containing antacids. Then magnesium containing antacids. First one is magnesium carbonate, magnesium trisilicate, and magnesium oxide. So magnesium containing antacids are these three: magnesium carbonate, magnesium trisilicate, magnesium oxide. Okay. Then combination antacid. The combination antacids are preparations are combination of aluminum hydroxide gel and magnesium hydroxide. Then combination of aluminum hydroxide gel and magnesium trisilicate. Then combination of aluminum hydroxide gel and calcium carbonate. Then combination of aluminum hydroxide gel and calcium carbonate and magnesium hydroxide. These are combination antacids. The first one is combination of aluminum hydroxide gel and magnesium hydroxide. Then combination of aluminum hydroxide gel and magnesium trisilicate. Then combination of aluminum hydroxide gel and calcium carbonate. Then combination of aluminum hydroxide gel, calcium carbonate and magnesium hydroxide. Rationale behind the combination of antacid preparation. First point is no single antacid meets all requirements for ideal antacids. So single antacids are not performed in ideal antacid. Hence many marketed antacid preparations contain more than one drug. So single drugs are not used in antacid. Single antacids are a good antacid. So the combination of antacids it means more than one drug. Okay. Then antacids are used in combination because to balance constipating effect of aluminum and a calcium antacid with a laxative effect and magnesium antacids. To balance the constipating effect in aluminum and calcium antacids with a laxative effect of magnesium antacid. The examples are aluminum hydroxide and magnesium hydroxide, then aluminum hydroxide gel and magnesium trisilicate. Okay. The next point is some antacid produces rapid onset of action. For example, calcium carbonate. And some antacids induce a slow action but for longer period. Example, aluminum hydroxide. So some antacids produce rapid onset, rapid action. For example, calcium carbonate. Then some antacids it is formed in slow action, but it is used for longer period. An example of aluminum hydroxide. The formula of aluminum hydroxide is AlOH thrice. Hence, to get rapid and a longer duration of action, antacids are used in combination. So, the rapid action and for long duration of action, so the antacids are used in combination. Few antacids contain antifluctuants. For example, simethicone, dimethicone, and reflux suppressants like alginic acid. So, some antacids are used as antifluctuants. They are simethicone, dimethicone, and reflux suppressants. Example is alginic acid. Then examples: aluminum hydroxide gel and magnesium hydroxide, aluminum hydroxide gel and magnesium trisilicate, aluminum hydroxide gel, calcium carbonate, and magnesium hydroxide. Then sodium bicarbonate and alginic acid, simethicone containing antacids, aluminum hydroxide gel and kaolin combination. These are the examples. Then first example is sodium bicarbonate. The molecular formula of sodium bicarbonate is NaHCO3. The molecular weight is 84 gram. The another name of sodium bicarbonate is baking soda, or common name of sodium bicarbonate is baking soda. Physical properties. It is white color, white or colorless crystalline powder. It is saline in taste. It is soluble in water but insoluble in alcohol. Its aqueous solution is alkaline nature. The aqueous solution of sodium bicarbonate is alkaline nature. So, sodium bicarbonate, the formula is NaHCO3. The common name is baking soda. Some physical properties. First one is white odorless crystalline powder. Then second one is it is soluble in it is saline in taste. Then it is soluble in water but insoluble in alcohol. For example, ethanol, methanol. Its aqueous solution is alkaline in nature. When it is treated with acid to form salt and water, sodium bicarbonate is dissolved with acid to form salt and water. It is stable in air, but in moist air it decomposes as sodium bicarbonate is stable in air, but in moist air it decomposed. Storage. Stored in well-closed container. Incompatibilities with the tetraacylane and acid salts. Preparation of sodium bicarbonate. Sodium bicarbonate may be obtained by the reaction of carbon dioxide with an aqueous solution of sodium hydroxide. Sodium bicarbonate is prepared. It is reacted with the carbon dioxide with aqueous solution of sodium hydroxide. The initial reaction produces sodium carbonate. Further addition of carbon dioxide produces sodium bicarbonate. So, carbon dioxide is reacted with the sodium hydroxide to form sodium carbonate. Then the sodium carbonate is reacted with the carbon dioxide and water to form sodium bicarbonate. Carbon dioxide CO2 plus sodium hydroxide NaOH gives sodium carbonate Na2CO3 plus water. Then further the sodium carbonate Na2CO3 is reacted with the carbon dioxide plus water to give sodium bicarbonate. Then uses of sodium bicarbonate. It is used as an antacid. It is used as systemic antacid in treatment of systemic acidosis. It is used as electrolyte replenisher. 3 to 5% solution in warm water. Then the sodium bicarbonate is used as an eye lotion. It is used as an ingredient of compound sodium bicarbonate tablets. Then it is also used in effervescent antacid. So these are the uses of sodium bicarbonate. It is used as an antacid. It is used in systemic antacid and treatment of systemic acidosis. Then electrolyte replenisher. 3 to 5% solution is dissolved in warm water to used as eye lotion. Then it is used as the most ingredient of compound sodium bicarbonate tablet. Then it is also used effervescent antacids. Assay. Weigh accurately 1 gram of sodium bicarbonate and it is dissolved in water, dissolved in 20 ml of water. This solution is titrated with 0.5 normal sulfuric acid, that means H2SO4. The indicator is used as methyl orange. So the end point is obtained. Each ml of 0.5 normal sulfuric acid is equal to 0.0425 gram of sodium bicarbonate. So the assay procedure is accurately weighed 1 gram of sodium bicarbonate and dissolved in 20 ml of water. This solution is titrated with 0.5 normal sulfuric acid added with methyl orange indicator. Each ml of 0.5 normal sulfuric acid is equal to 0.0425 gram of sodium bicarbonate. Okay, these are the assay of sodium bicarbonate. So today we will discuss the topic gastrointestinal tract agents. First, the definition: gastrointestinal agents used in the treatment of gastrointestinal disorders. It is called as gastrointestinal agents. Then these are the classification. First one is gastric acidifiers. Then second one is antacids. Antacids are classified in two types: systemic and non-systemic antacid. The non-systemic antacids are further classified: aluminum containing antacid, calcium containing antacid, magnesium containing antacid, and combination of antacid. For more examples are combination antacids. Then third type is protective and adsorbents. Then fourth type is cathartics. Then achlorhydra definition: it is no secretion of hydrochloric acid in stomach. Then reasons of achlorhydria. Then discuss the drugs used in the treatment of achlorhydria. Most important drug is hydrochloric acid. Then the hydrochloric acid properties and so on. The uses of hydrochloric acid is an acidifying agent. It is used for excretion of alkaloids and gastric acidifiers. Then second one is antacids. Antacids are the drugs which are usually weak bases used for neutralizing excess acid in the stomach of the patient suffering from hyperchlorhydria. Then ideal characteristics of antacids. Then classification of antacids. First one is systemic antacids. It is also called as absorbable antacid. Then second one is non-systemic antacids. It is non-absorbable antacids. The non-systemic antacids are further classified as aluminum containing antacid, calcium containing antacid, and magnesium containing antacids, and combination antacids. Some rationale behind the combination of antacid preparations. Then examples: aluminum hydroxide gel and magnesium hydroxide, aluminum hydroxide gel and magnesium trisilicate, so on. Then the example is sodium bicarbonate. Another name of sodium bicarbonate is baking soda. So discuss the physical properties and the preparation. Carbon dioxide is reacted with sodium hydroxide to form sodium carbonate. Then further sodium carbonate is reacted with the carbon dioxide to form sodium bicarbonate. Then uses of carbon dioxide. It is used as an antacid. It is an electrolyte replenisher. It is 3 to 5% solution in warm water. It is used in eye lotion. It is used as an effervescent antacid. It is an important ingredient of compound sodium bicarbonate tablets, etc. Then assay: 1 gram sodium bicarbonate is dissolved in 20 ml of water and titrate the solution with 0.5 normal sulfuric acid. Methyl orange is used as an indicator. Each ml of 0.5 normal sulfuric acid is equal to 0.0425 gram of sodium bicarbonate. Okay, thank you students.